Today we're going to talk about parallel and perpendicular lines. So let's type in a description of parallel. Parallel lines are lines that never intersect. Bless you. If they're parallel, then they will be going at the same rate and either both positive or both negative. So our slope will have the same rate, so that means same slope. But then the y-intercept is going to be different. I guess I could just type same and different. There we go. Parallel lines have the same exact slope, but the y-intercept will be different. Okay, so over here it says write the equation of the line that passes through this point. Negative 2, 7 is parallel to the line y equals negative 4x equals 1. So if they're parallel, they're going to have the same slope. What is the slope on example 1? Negative 4. So let's write that. M equals negative 4. And it's going to go through negative 2, 7. I'm going to write that. Negative 2, 7. So we need to write the equation for the line that has a slope of negative 4 and a line of negative 2, or a point of negative 2, 7. So let's look at our journal. I'm going to put parallel lines. Parallel has same slope, different y-intercept. Okay, so we are on slide 15. We have the slope of negative 4 and a point. What was that point? What was the point that we were given on the first example?
Negative 2, 7.
Okay. So we need to write the equation of this line. So think back to last week how we wrote equations. We could either do y minus y1 equals mx minus x1 to write the equation, or we can do y equals mx plus b to find b. Which one did you like better? Y equals mx plus b and find the b? Yeah, I think a lot of people liked it that way too. Okay, so we are going to plug in the x, the y, the m to find the b. So y equals mx plus b. I'm going to plug in my numbers. So this would be 7 equals negative 4 times x, which is negative 2, plus b. So it'd be 7 equals negative 4 times a negative 2.
8, positive 8.
Yeah, positive 8 plus b. We need to solve for b. So subtract 8. Negative 1 equals b. So our equation is y equals, our m is negative 4, so negative 4x
Minus 1.
minus 1. Okay, y equals negative 4x minus 1. And we're going to graph this in our journal. So you do need a ruler. There are rulers at the front of the room and also at the back of the room. Grab a ruler. You need to draw an x and y graph, x and y axis. Whatever I had back there. Oh, there might be one on that.
Here we can share it.
There you go.
Still share.
Okay, draw your x and y axis. And we're going to write both equations down. So this was the one that we got. And then the other one was negative 4x plus 1, I believe. This was our original or our given. So we need to graph both of these. So the first one is at positive 1. The y-intercept is at positive 1. And then we're going to go down 4, right 1. So go down 1, 2, 3, 4, right 1. And draw your line. And then the one that we got that's parallel that goes through negative 2, 7 is the y-intercept of negative 1. And then down 4 over 1. Down 1, 2, 3, 4 over 1. Okay, so see how they're parallel? They'll never touch. Same slope. The negative 4 is our slope. Different y-intercept. Okay, let's go to the next one. Write an equation of a line that goes through 3, negative 1 is parallel to x minus 3y equals 9. So I'm going to write x minus 3y equals 9, and then the point 3, negative 1. To find the line that is parallel, I need to find my slope. From this, I don't know the slope. So I need to solve this for y. How do I solve it for y?
Oh,
Move the x first, so minus x. Negative 3y equals negative x plus 9. And then divide by the negative 3 all the way through. I get y equals negative divided by negative becomes positive. X over 3. And then what about 9 over negative 3?
3.
Negative 3.
Negative 3.
Yeah. So what is the slope on this?
1/3.
It'd have to be 1/3 because it's with the x, but there's nothing in front of x, so I put a 1 there. So my m is 1/3. So this is my original. Whoa. Okay, so we need to find our new line. So this is my x and y. It goes through this point and it has a slope of 1/3. So we'll write y equals mx plus b. And we're going to plug in x, y, and m to find b. So y is negative 1 equals m, 1 over 3, times x, 3 plus b. What is 1/3 times 3? It's 1. So it's negative 1 equals 1 plus b. Then we subtract 1 on both sides. Negative 1 and negative 1. Negative 2. Okay, so then our new equation is y equals 1/3 x, because that's our slope. And then our b is negative 2. Okay, we're going to graph it. Okay, let's graph the original. This is our original. Our y-intercept is at negative 3, so let's plot a point at negative 3. And our slope is 1 over 3. So we rise 1, run 3. Rise 1, run 3. And then the new one is 1/3 x minus 2. So we start at the y-intercept at negative 2. Rise 1, run 3. Rise 1, run 3. Down 1, left 3. Down 1, left 3. So see how they're parallel? Same slope. They're never going to intersect. And then our new line, this line, the purple one, the one that I did purple, does it go through 3, -1? Over 3, down 1. And it sure does. Okay, so that is parallel. Those are parallel lines. Okay, so let's put it in here. Our slope was 1/3. And our point was 3, -1. And then our equation came out to y equals 1/3 x minus 2. Okay, we're going to skip 16, 17 for now, and we're going to go to 18. Perpendicular lines. Description of appearance. What do y'all remember about perpendicular lines? Yep. Intersect at a right angle. So it kind of makes a T. So if I have one line like this, then the other line will be like that. So it intersects to make a T. And remember how to make it look like it's a right angle? You put that little box in there. Do y'all remember that? There we go. It's kind of like that. Okay, so that would be perpendicular. If let me see, I'm going to use this. I can rotate these. See how it's still a right angle? If I rotate them together, that still makes a right angle. I'm going to get rid of that though. It still makes a right angle. So it doesn't have to look straight like a T, but it does have to cross at a 90-degree angle. So if I look at these two lines, this line would be considered negative slope, right? And then this one would be a positive slope. So perpendicular lines are going to have opposite signs as their slope. And they're also going to have a flipped rise and run. So if one of them rises 2, runs 3, then you're going to flip it. It's going to rise. The other one will rise 3, run 2. That's called a reciprocal. So our slope is going to be the opposite reciprocal. So opposite means different sign, and flipped fraction. Fraction means fraction. The reciprocal means you're going to flip the fraction, flip the rise over run. So I'm going to put that in parentheses. There we go. And then the y-intercept can be same or different. It could be any. Okay, in your journal, we're going to write perpendicular lines, slope, opposite reciprocal. And this is, what slide are we on?
Slide 18.
Okay. Okay. Remember, perpendicular lines have opposite sign and reciprocal or flipped slope. We're going to look at this first one. So it says, write the equation of the line that passes through 4, 3 and is perpendicular to the line y equals 2x minus 4. Okay, so our slope on this one is m equals 2. Our perpendicular slope is going to be, if you flip that. So this is like 2 over 1, right? Our perpendicular slope is going to be the opposite of 2 over 1. It's going to be the reciprocal and also change the sign. So instead of 2 over 1, it's going to be negative 1 over 2. So we're going to write the equation of that line. So our original was y equals 2x minus 4. So our m here is positive 2 over 1. So then our perpendicular slope is going to be negative 1 over 2. And look on your digital journal, what point did it say it went through? What point is that on your digital journal? What is it? 4, 3? Okay. Okay, so let's write the equation. Let's find the m when we're given the x and y and the m. So this would be y equals mx plus b. So we have 3 equals negative 1 over 2 times x, which is 4, plus b. So we need to solve for m. So we need to go and multiply negative half of 4. Negative 2. So 3 equals negative 2 plus b. We're going to add 2 to both sides. 3 plus 2 is 5 equals b. So then our equation is y equals negative 1/2 x plus 5. Draw an x and y axis so we can graph them. So we can graph our first one. the y-intercept is at -4. And our slope is 2. So up 2 over 1. Okay, now do the other one. Y equals -half x plus 4. I mean plus 5. And then down 1 over 2. So it's +5 down 1 over 2. Down 1 over 2. Okay, so one's positive, one's negative. And then they have the opposite slope. One of them is down 1 over 2. The other one's up 2 over 1. This makes a right angle. Do the little right angle symbol. And then that is our equation. Okay, I do want to show you this in the calculator, though. So get out your calculator. Clear what's in there. Because something we need to look at with perpendicular lines when we graph in the calculator. So everybody go to y equals. Everybody should be on your calculator, right? Okay. So we have 2x minus 4 is our original. And then the one that we just found is -half 1 over 2 x plus 5. You should have this in your calculator. I see some of you just playing with a ruler. Okay, then go to graph. And we'll look at it. Okay, on our paper, it looked perpendicular, right? But in the graph, it doesn't. It's because our graph, the scales are different on the X and the Y. So what we're going to do is go zoom, square. We want to square this up so it looks equal. So zoom, and then number 5 is square. Once you do that, it's going to make it look exactly like it should, which is a right angle. That looks way better, right? The other one, see how these are the exact same distance apart as on the y-axis? Earlier when it was on standard's what it's defaulted to. See how those are separated a lot further on the x-axis than the y-axis? So whenever you want to look at it the way it should look, you go to zoom square. And that's the best way. Okay, now look at the paper that I gave you. Oh, we need to put this in our digital journal real quick. And then we'll look at the paper I gave you. So y equals -1 over 2x plus 5. You put a space after the 1 over 2, it'll actually make it look like a 1 over 2. We're going to wait on example 4. We're going to look at our paper now. Go ahead and write your name on it. And let's fill in what we know. Parallel lines. Let's draw an example right here. Let's write never intersect. It's like train tracks. They always have to have the same distance apart. What do we know about the slope on parallel lines? Yep. Perpendicular, opposite, reciprocal. And they intersect at a 90 degree. I should have wrote opposite reciprocal over here. Intersect at a right angle. Okay, now look at our table. We have slopes on here. We're given an original slope, and we want to write what the parallel slope is and what the perpendicular slope is. So I'll do the first one with you, 2/3. Parallel slope is going to be the same. So the parallel slope is 2/3. Perpendicular will be opposite reciprocal. So it'll be -3/2. Okay, go ahead and do the next line. It says the parallel slope is -1/2. So what's the original? What's the perpendicular? Original should be the same. Perpendicular, you flip and change the sign. So it's 2/1 or just 2. Okay, the next one. If they give us a perpendicular slope is -5/6, what's the parallel? What's the original slope?
6/5.
Yeah, 6/5. So you go from perpendicular over to original, and then what's the parallel slope? 6/5. All right, go ahead and fill in the rest of this chart. Shouldn't take very long. All right, now look at the back. You're going to classify each set of lines as parallel, perpendicular, or neither. You've been given a graph. You've been given 2 sets of lines, and you're going to graph them and then identify them as parallel, perpendicular, or neither. The first, 2 are pretty easy because they're already in y equals form. Let's look at This one over here. Everybody go to that one. Y equals 7x plus 2. And then we have x plus 7, y equals 8. So this can already be easily graphed, right? We need to solve this one for y. So how do we solve that for y?
Use characteristics on both sides.
Okay. Divide by 7 all the way through. So y equals negative 1 over 7x plus 8 over 7. Before we go and graph it, we can already tell if it's parallel, perpendicular, or neither by looking at the slope. What is the slope of the original, or of the first one? Just 7, yeah. What's the slope of the other one?
Negative 1 over 7.
So yeah, it'll be perpendicular. Okay. So since I have this, let's go ahead and graph it. The first one will be easy to graph. We plot the y-intercept at 2. Then we go up 7 over 1. And then down 7 over 1. Okay, then the next one is a little bit harder, right? Because we have a y-intercept that's a fractional part. So this is where we can use our calculator. Because what we want to do is we just need to find 2 points in order to graph it. So go to y equals, and let's put that equation in. Yep, that's negative 1 over 7x plus 8 over 7. All right, so we have that. So where can we go to find points? The graph, easier, the table of values. So we just need to find 2 points. And we don't want fractional points. We want whole number points. So if we look at this, what whole number point do we see? Okay, so 1, 1. Okay, and then let's find another one. We can go up or down. 8, 0. What was it? Negative 6, something else too? Okay, 8, 0 is also 1. 1, 2, 3, 4, 5, 6, 7, 8. Remember, the slope is down 1 over 7, so we could have just used this point and went down 1 over 7, which is the same thing. Okay, so connect those. And we're done. And we know it's perpendicular, so we can go ahead and put that little right angle box on there. Okay, so your assignment is to finish these. There's 1, 2, 3, 4, 5. Actually, I'll let you skip 4. So just do all of them except for the 4th one. So y'all see how mine is listed? You can skip this one, but do those. You just have 4 problems to do.